school at the university, and he just minimally think. Because you go to classes on quantum mechanics, and you get the explanation of the world, and the world is all about discreteness. Think, the light is photons, it's just discrete particles. The elementary particle bits of things. Everything is in bits and chunks. It's probabilistic. Things jump from one to another. And there is this strange interactive thing for which in quantum mechanics you predict how things interact with one another. So you say, okay, that's the way reality is. I mean, okay, God did reality that. I mean, we don't know what she thinks or why, but that's where reality. And then you go to the other class, or this other teacher that teaches you about general relativity. And this is, equally immense, fundamental, successful theory. And the universe is continuous, it's perfectly continuous. There is nothing probabilistic. There is, deterministic equations of motion. Everything is perfectly objective out there. You can write the history of space-time in a single equation. And then I think, wait a minute. I mean, either one or the other, they cannot be. I mean, my teachers stopped talking to one another, haven't talked to one another for 30 years. And they're both professors of physics with a PhD and tenure. So it's really two totally different images of how reality works. And, God can be complicated, I don't know, but not so self-contradictory. The world is either this way or the other way, or some way which is compatible with both. But what is the one that is compatible with both?
And is that the quest with quantum gravity?
And speaking of quantum gravity, as part of this show, we collect questions from other listeners. And a mutual friend of ours, Carlo Lynching Chen, she's a postdoctoral researcher in Brussels, Belgium. She sent in a question for you.
Oh, fantastic.
Hi, Carlo. This is Lynching. So in our quest for a theory of quantum gravity, do you think we will need new fundamental principles that both quantum mechanics or general relativity have not yet revealed to us? And what is your strategy for finding them out? Thank you.
That's a great question. Indeed, she's fantastic. And it follows immediately from what you were asking before. The answer I have, I'm not sure, but the answer on which I'm working is no. No to the question, do you think there is some fundamental principle that will be missing? And I think that the idea that, we're missing something crucial, fundamental down there is just wrong. The point is that we have to take seriously what we learn with quantum mechanics and seriously what we learn about general relativity and bring them together. And they do go together. You just have to rearrange things and to understand that. So I'm a very conservative guy from this perspective. I don't believe we need something new. Supersymmetry, other worlds, many dimension, breaking of Lorentz invariance, correction to quantum mechanics. Nature has been saying no to all the attempts to test this alternative hypothesis so far. So I don't see any evidence that we're missing something. It's just that general relativity, it's about space-time. So it's a shape of space-time, shape of space and shape of time, which means how different clocks move with respect to one another and how meters measure geometry. And that's quantum. And so we have to understand the quantum properties of time and the quantum property of space. And, that's radical. So the assumption is conservative, but if you follow up, this is completely radical because it means it's a continuous space that you thought was, forget about it. The time evolution in a single variable, forget about it. You have to replace the usual way of thinking space, the usual way of thinking time, with something consistent with quantum mechanics, but not this quantum mechanics in space-time, quantum mechanics of space-time. So, for instance, you have to have a mathematics and a physical intuition that allows you for having quantum superposition of space-times, plural, of geometries. Like there is a Schrödinger cat that can be both awake and sleep, or somebody said dead and alive, and alive. I don't like
I
that.
like your version better. I like cats. So.
Yeah, exactly. So Schrödinger cat in quantum mechanics can be both awake and sleepy, and sleeping. And so in the same sense, space can have a shape and also another shape in a superposition of the two. And of course, this requires imagination, finding the right concept to talk about that. That's also where philosophy comes in useful, and the right mathematics. And I think loop quantum gravity is an example of a theory that attempts to do that. We don't know if it is right. It's very conservative, and that's why the answer to Lichi's question is no. So there's no other principle to be added, but it's completely radical then because it forces us to rethink the basic notions.
And you mentioned evidence when you were giving this explanation, looking for evidence to support various theories of quantum gravity. What kind of evidence would you be looking for?
I think that recently there have been a lot of evidence that helps us. And in science, evidence is never definitive. It's always indications, like in life, by the way. So it's not that you kill theory. It's very rarely that you really, really kill a theory with an experiment. But you create problems to a theory. And when the theory has too many problems, you look somewhere else. And there have been a lot of these things recently. The strongest and the most unexpected for many people has been the absence of low-energy supersymmetry. There was a big part of the community that was completely convinced, sort of 99.9%, that supersymmetry was going to be detected
by the Large Hadron Collider?
At CERN, right, with LHC, and it wasn't. It was a shock. There was title of the journals like, this is a crisis of physics. Of course, it's not the crisis of physics. It's only the crisis for those who expected it.
Right.
Which is not physics. It's just a particular school of thought. But that's nature talking. And when nature talking, we should listen, I think. Another example, it's breaking a lot of Lorentz invariance, the symmetry at the basis of Einstein's special relativity is Lorentz invariance. Some people thought it was like supersymmetry. It was a very good, very nice idea. You can make the problem of quantum gravity easier if you don't have Lorentz invariance. So people try to write theories which break Lorentz invariance and might be quantum gravity theories. So this was tested, 10 years of, 15 years now of astrophysical observations, and all the expected signs of breaking Lorentz invariance, 0. So once again, nature talks. As far as we know, nature is saying, no, guys, that's not the right way to look for the solution. So I think nature is giving indication. A lot of people expect a negative cosmological constant. Even today, there is a large part of the community that continues to do calculations with a negative cosmological constant. It's called ADS-CFT. ADS means anti-de Sister, which means it's a space with an effective negative cosmological constant. Except that the cosmological constant has been measured by the astronomers, by the cosmologists in a very convincing way. They got a Nobel Prize, the ones who did that, and it's positive. So once again, I think my interpretation, my reading of that as a scientist, I might be wrong. I know I might be wrong. But my reading of that is that nature is talking, listen, that's not the right direction to go.
So what will nature say to you? How will nature speak to you to advance loop quantum gravity, say? What signs are you looking for?
There are 2 or 3 directions where me and many of my colleagues are looking into. For the moment, 0. So we have no negative response for nature, but we don't have any positive response for nature.
Can you explain that a bit?
We don't know. So there's nothing that has come as a sort of contradiction to what we expected, but there is nothing that has come to confirm predictions of the theory either. So I cannot say that loop quantum gravity is confirmed in any sense. It's a tentative theory. It's just out on the table, and let's see. So where could the confirmation could come from? I see 3 possible directions. One is early cosmology. There's a lot of literature, papers